In early October 2025, the Philippines was jolted twice. On September 30, a magnitude 6.9 struck northern Cebu at night. 9 days later, a magnitude 7.4 off eastern Mindanao was followed hours later by a 6.8. These were not random. They were linked chapters in the same tectonic story. The Philippines lies in one of the most earthquake-prone regions on Earth. In a typical year, dozens of quakes reach magnitude 5 or 6, and often at least 1 or 2 reach magnitude 7. Large earthquakes are dramatic, but not unprecedented here. Why does the Philippines shake so often? And why did 2 big quakes arrive 1 week apart? To answer this, we need to look deep beneath the islands. The short answer is that the Philippines sits at the crossroads of multiple tectonic plates. Unlike, say, Chile or Japan, where one subduction zone dominates, the Philippines is trapped between 4 major plates. Imagine an intersection where eastward-moving and westward-moving tectonic highways all meet. This unusual setup explains why quakes can cascade across the country in quick succession. Geologists call this region the Philippine Mobile Belt. Over time, several big plates squeezed and stitched the archipelago together. 4 push on it today: the Eurasian or Sunda Plate, the Philippine Sea Plate, the Pacific Plate, and the Indo-Australian system to the south. Their forces meet around the islands and load the crust with stress. On the western side of Luzon, the Sunda Plate, part of the Eurasian Plate, pushes east and dives beneath the Philippine Islands at the Manila Trench. This process is called subduction. It helped build the Sierra Madre and Cordillera ranges and fed volcanoes like Pinatubo. The boundary is mostly locked, so strain is building and could release in a large event. Convergence here is measured in centimeters per year, slow but relentless over time. Now flip to the eastern side. East of Mindanao and eastern Luzon, the Philippine Sea Plate sinks along the Philippine Trench and the East Luzon Trough. These deep boundaries can lift the seafloor during large slips and can generate tsunamis. The October sequence off Mindanao involved this subduction system, which is why the area is closely monitored. In southern Mindanao, the Cotabato and Sulu trenches mark another collision zone. In 1976, a large earthquake here generated a tsunami up to several meters high and killed as many as 8,000 people. These faults are quiet today, but continue to reload strain. From the northeast, the Pacific Plate adds a sideways push through the Philippine Sea Plate. This extra force tightens the system, especially in northern Mindanao and eastern Luzon. So, what does this all mean? The Philippines is not sitting on a single fault. It is being pushed from the west, east, south, and northeast at the same time. The crust bends, cracks, and slips, so earthquakes occur across the islands. Some are subduction quakes that can lift the seafloor. Others are strike-slip quakes on inland faults that shake cities hard. This interconnected tectonic knot explains why the Cebu quake and the Mindanao doublet occurred only days apart. As long as plates keep pushing, more earthquakes are expected. The question is where and when. The Philippines sits inside a ring of trenches with different rhythms. Manila looks quiet but is largely locked, so strain is building. The Philippine Trench slips and bursts, as seen in the October doublet. Cotabato and Sulu have a known tsunami history. Together, these trenches outline the Philippine Mobile Belt. Plates push from west, east, south, and even the northeast, keeping constant pressure on the crust. Some faults slide sideways, some thrust and lift the seafloor. That is why big earthquakes can strike in different places within a short time. Beyond the trenches, the Philippine Fault Zone runs more than 1,200 kilometers from Mindanao through the Visayas to northern Luzon. It accommodates sideways, strike-slip motion, and can rupture after long, quiet periods. Metro Manila sits beside the West Valley Fault. A magnitude around 7.2 here could cause severe damage across the capital region. Other active faults lie near Davao, Kidapawan, and General Santos. Inland quakes do not usually generate large tsunamis, but they can produce intense shaking and major urban losses. Preparedness in these areas is essential. Tectonic plates move a few centimeters per year. In the Philippines, some boundaries converge at about 8 to 10 centimeters per year. The motion is steady, the rocks resist, and strain builds. When stress exceeds friction on a fault, the rock breaks and an earthquake releases the stored energy. Then the cycle begins again. After a quake, the crust rebounds, but the plates keep pushing. The seismic record is like a heartbeat, sometimes quiet, sometimes busy, always ongoing. Over time, these processes reshape the islands. Mountains rise little by little, trenches adjust, and faults lock and unlock. Earthquakes are not fully predictable. We can identify stress zones and track patterns such as foreshocks, ground tilt from GPS, and other anomalies. AI tools can flag unusual signals, not exact times. That is why timing still surprises us, even when we understand the overall pattern. One important idea is stress transfer. A large slip changes the stresses around it, which can make nearby faults more or less likely to rupture. The first Mindanao October quake likely increased stress on a neighboring patch that failed hours later. The Cebu rupture may also have shifted stress within the regional fault system. A quake does not only relieve tension, it redistributes it. No part of the Philippines is completely safe from quakes. Volcanoes dot the landscape, and faults run across nearly every major island. The country's uniqueness lies in this complex intersection of hazards. Two major trench systems on opposite sides, multiple smaller trenches, and a long strike-slip fault slicing through the archipelago. Pressure comes from every direction. Because of this multi-sided squeeze, it is not about if, but where and when the next rupture will begin. The best approach is to identify likely zones by mapping stress, historical ruptures, and geological structure. Then prepare accordingly. Scientists and agencies monitor seismic networks and GPS stations every day. After the October pair, PHIVOLCS logged hundreds of aftershocks within hours, a tight cluster showing the Philippine Trench was still active. Beyond aftershocks, monitoring looks for trends. Changes in the rate of small quakes and subtle ground motion seen by GPS or satellites. Attention is focused on reports of microtremor clusters in parts of Mindanao and possible small ground changes around Samar and northern Luzon. These observations guide monitoring, but they are not predictions. Some teams test AI tools that scan seismic and geodetic data for unusual patterns. These tools can flag anomalies, not exact times. There's no bulletproof earthquake alarm. Real-time alerts exist for shaking that has already begun. Scientists also watch for quiet stretches called seismic gaps. A long, quiet segment can mean strain is building. The Manila Trench and the Cotabato Trench have been comparatively quiet in recent decades, despite fast convergence, so they remain high-interest areas. By contrast, places with frequent small quakes may be redistributing stress. That can delay a larger rupture or not. Nothing is guaranteed. We cannot forecast the exact day or place, but we can outline realistic scenarios based on how this plate system behaves. Scenario A, a Manila Trench megathrust. A major slip on a locked section of the Manila Trench could drive fast local tsunami waves toward western Luzon. Communities from Palawan to Batanes should know their evacuation routes and closest vertical shelters. The level of shaking on land would depend on which segment ruptures and its depth. But for nearby coasts, the first waves could arrive quickly. Scenario B, a Mindanao follow-on. Another strong event could occur along the Philippine Trench if a nearby patch has loaded, or on the Cotabato Trench if regional stress shifts south. Mindanao's coasts could face tsunami risk. Inland shaking could be severe in Davao, Surigao, or Samar if rupture interacts with nearby crustal faults, or if local soils amplify motion. Scenario C, a hidden local fault near a city. A smaller quake on an unmapped or lesser-known fault can still cause major local damage. The September 30 Cebu rupture on the Bogo Bay Fault reminded us that not all active faults are well known. Local proximity matters more than magnitude alone. The twin earthquakes of October are chapters in a long tectonic story. The ground in the Philippines is always moving. We cannot stop it, but we can understand it and prepare. Which zone do you think is most at risk next? Luzon, Visayas, or Mindanao? Tell us why in the comments, and follow PHIVOLCS for official guidance.